So now that in the previous video we did have a look at how we can use script in general to interact with a transaction, and we saw how really all that scripts are doing is just adding additional rules to a transaction for it to be valid. And we did that using native scripts, which only allow for a very strict set of rules, but are also really efficient for those rules. Now we can move to Plutus scripts and see what are the main differences with native scripts. We will focus primarily in this video on the off-chain differences, and then we'll slowly approach on the on-chain and how to actually describe these more complex rules that is possible to describe using Plutus, which is Turing complete. So as you can imagine, it has all the features of a complete programming language, contrarily to native scripts that are instead essentially just a JSON object. So really simple, but also pretty limited. Instead, now we'll start having a look at Plutus scripts. So in this course, we will focus only on Plutus v3. There are not a lot of differences between Plutus v3 and the previous Plutus v1 and Plutus v2. So in this course, we will focus on Plutus v3, and we'll see in a second why we will focus only on Plutus v3, as we did hint in one of the previous videos. Mostly, we want always to use the latest version of Plutus, because everything that we could have done in the previous versions, we very likely can do also in the latest one, with additional efficiency improvements sometimes, or functionalities that even were not present in previous versions. So overall, you always want to go with the latest version. The interface of a Plutus script is really a function, actually a plu-ts function in this case, that we can declare using pfun. We will see all these keywords and stuff in general that is exported by plu-ts in order to describe your own chain logic later in some videos in the future. But essentially, as you see here, all we are doing is declaring a function type and implementing the function using normal JavaScript syntax. And the interface for Plutus v3 is a function that takes some data, and when we talk about data, you should automatically connect it to what we saw over here when we explore the transaction output class, which is a resolved UTXO essentially. So and we saw that we can attach a datum that is nothing else than data to an UTXO. And of course, the data can be somewhat structured, and as we will see in a few videos from now, not too far from this video, we can on-chain assign types to this structured data, so that we don't have this generic thing. And so for Plutus v3, we expect some data, and we expect actually the Cardano node expect in return a unit. A unit you can see if you come from the Typescript world as the type void. It is not really a value, or actually it is a value, but it is a value with only one possible value. That is why it's called a unit. So it is not a meaningful value. Why do we return a unit? Because, as we will see in this video, all that Plutus script cares about is if a script, so the execution of this logic, either fails, and with fails I mean it throws an error, or it doesn't. So it returns really whatever value. It is a common practice, and it is actually probably best practice to return a unit and in the future it may even be enforced due to how much it is used to return a unit in a smart contract. So the standard interface that we want for a function is something that goes from a generic data from now to a unit, and in doing so it can express arbitrary logic based on the input data that we are receiving, and that we will see in a bit what is really in this data. Based on that data, it runs some logic, and while it runs the logic, it can either throw an error or don't. And if, of course, we reach the end, so we return something without further proceeding, then we didn't throw an error, and in that case, the Cardano node will assume that the additional rules specified in this Turing complete script are all respected because it didn't throw. So based on this information, you can already tell that this script that we have right here is really simple, and all it is doing is taking whatever data the Cardano node is giving us and returning directly without even looking at the data. In fact, you see this context is not utilized, and returning directly a unit. That means that there is no error. And so that means that this contract actually does not really add any logic, does not really add any rules. And this is the classic example of an always succeed Plutus script. So once we have a contract that we define like this, usually you have a PFN for function, because of course of the interface that you expect. We have some contract thing that we can pass to the compiled function. The compiled function, as you see here, takes a term as first and only required argument, and this contract is indeed a term with some other extension, but really what we are interested in is a term with some type. Well, as you can see already here, that it is a lambda that goes from data to unit. But this is not really important for now for the compile function. The only thing that it cares about is that the term is there. Optionally, you can also specify a version. However, this version is not the Plutus version. It is something lower level. It is the version of UPLC that you're using. This is really low level, so you should not be worried about it. Usually, the correct version will be used by default. Maybe the only difference that you may want to use is only if you are using an older version. So as an example, if you're using Plutus v2 or Plutus v1, like this, okay? So in that case, probably you want to specify version to be 1.0.0, and that's it. But in this case, we want to use Plutus v3, as mentioned before, so we are good with whatever version is being used by the compile function automatically, which I can tell you is version 1.1.0, but it doesn't really. So once compiled has done its thing, it returns a uint data array. So it returns a bunch of bytes, a buffer if you want. So here we have a bunch of bytes that are exactly what we want to pass to the script interface that we saw a couple of videos ago. So here we have our script. We specified that it is a Plutus v3 script. We pass the compiled contract that we have here. So we pass the on-chain logic, and this script we can then use to, as we know, get an address using credential.script and passing the hash of the script. We get an address for testnet, since we are of course in testnet, and we do the usual stuff. At this point it might even be boring to you because we are just getting our transaction builder using the block protocol parameters. We are building our transaction using one of our input present at our own address. We want at least 12 ADA. If you remember, these are levelaces. So we want at least 12 ADA as input for the UTXO that we are going to use. We set the change address to be ourselves, and we send 10 ADA to the script address that we got here. So this is a simple transaction. We are funding the script. We are getting something a bit more than what we want to send, because the transaction builder, as you remember, is also setting the transaction fee already. So of course, we will send 10 ADA to the script address, and we will need something, a little wiggle room for the transaction builder to do its thing. And then whatever is left, we will get back to our address. Of course, then we sign the transaction that we just built. We show it just to make sure that we have everything right. And then we submit transaction. This is of it. As said before, this is at this point even boring. So we can just npm run fund. And now we see that this is the hash of the script that we have here. The always succeed script in this case, the very simple always succeed. And remember that the hash, I did not mention this before, the hash is strictly dependent on the logic. So if you have the exact same source code of the contract, then you will get the exact same bytes of the compiled contract. And this exact same bytes is what then determines the hash. And then this hash is what determines, of course, the script address. So for the same exact on-chain logic, the same exact Plutus script, you get the same exact address. And this is our address over here. We see then that we are taking an input from our own address with some ADA and adding one output to the script address that we check is the same, then ADA as specified, and the rest goes back to us. This has been handled by the transaction builder. The fee, the network, all seems good. We have signed the transaction, and this is the link. And we can also check, since we are using the Eternal wallet, that the transaction is indeed here, and we have successfully sent an ADA to our Plutus script. So going back, we can try now instead to spend. And this is the interesting transaction instead, because if you remember, we do not call the on-chain logic when we send funds from to the script. Instead, we run this logic, so this Turing complete contract, only when we spend or do some other action, but not when we send to. So when we try to spend from the contract address that we just sent to, we are actually running the contract. Now, in order to correctly include a Plutus script, we of course do not want to use the native script option because it is not a native script. Instead, we have a bunch of ways to include a script. So the other two ways are actually either input script or reference script. Reference script is a bit more advanced. If you remember over here on a UTXO, we can add a reference script, and these are defined. We left undefined only because we did not yet introduce the script type, but here you would attach a script if you wanted to, and the resulting UTXO that has a reference script could then be used as a lightweight to include a script into the transaction, because actually only the UTXO reference goes into the serialized transaction, and the Cardano node is able to retrieve the script from the information that is already on chain. Of course, that is a bit more advanced, and we will see how to use reference script in one of the future videos. But for now, we are not interested in that level of complexity, so we will go with input script. Input script actually requires a bunch of information, not only script, and so we need an object and specify those informations. You see that you have to specify a script, you have to specify a redeemer, and you may or may not specify a datum. You need to specify a script, of course, and then here we will be using our script. Here we will be using our script that we have here. And then we also need, you see, input script is complaining because redeemer is missing. And of course, we need to specify a redeemer. Now, this redeemer, what is? It's nothing else that a fancy way to specify that this is a data. Now, why do we need this redeemer thing? If we go look here at the script, we specify this data that is very generic, but in reality, we know already that this data comes from the Cardano node, and we will see that this data comes from the Cardano node and is of a standard known type. So here instead, the correct way to address this type is this script context. This is the name of type. And now this context, since it has a structure, we can also access it in a somewhat fancier way, and it gives us access to a bunch of information about the script and where it is run. That is why it is called script context. The information that we have here is namely the TX field, which gives us a lot of information actually, and it gives us all the information regarding this transaction that is the script is included in. The purpose that we will see very likely in the very next video, and the redeemer. So you see that between these fields that must be here in order for the script to run, we have the redeemer. So without a redeemer, we have no way to run a Plutus script because something is missing there. So here we pass it in indeed the redeemer. The redeemer, as said before, is just data. So here we specify just some not really important data, because in this script is not, in this particular script is not used. But in more complex script, it is a somewhat important piece of information that comes from the off-chain. This particular piece of information, the redeemer, is really important to communicate in the moment of using the script, to communicate from the off-chain to the on-chain with the script. So here we have our redeemer, and for this particular use case, the datum is not needed. Just be advised that if instead of a Plutus v3 script, you are using a Plutus v1 or a Plutus v2, Instead, you will need, at all costs, even if you don't use it, to specify a datum. For Plutus v3, this is optional, and in our case, is not even needed. But a datum is also another important piece of information. Also, the datum is of type, the same type of the redeemer. Of course, can also be undefined, but it is, if specified, it is of the same type of the redeemer, and it actually needs to be specified only in rare occasions. Most of the time, the datum will already be present on UTXO, as we know from the video where we saw how a UTXO is actually formed. So this is our input. We have the change address, so we don't even need at this moment to send transaction, since we do not have any input from the address, our own address. The only input is of the script. So in theory, it should be all good, right? Well, let's try to see what the Cardano blockchain thinks about this transaction by running npm run spend. Let's see. Okay, so as you can see, even if we changed the logic here, in reality the compiled output is the same, since we are still not using the input and still returning the same unit. So the hash is the same, and as the address, you can check going back in the video, is exactly the same. Yet we get an error from the transaction builder. The error says collateral missing and no input could be used. What is this collateral thing? Well, since we are using much complex scripts, these contracts are Turing complete. Remember, the Cardano node cannot be entirely sure prior running this potentially complex script. In our case, it's not that complex, of course, but it could be. Prior running the script, it does not know how much resources it will cost. So prior running the script, it does not know really if it was submitted respecting all the rules. Yes, we are paying somewhat an additional fee in order to run this script, but we are not sure until the script is run, and so until some resources are spent in order to run that script, if it actually does not throw an error, so the script is valid. And to cover for this uncertainty, the Cardano node will require us to specify some collateral value in case we are lying to them. So if we lie to the Cardano blockchain and send a script, we submit a transaction that includes a Plutus script, and that script fails, so the rules specified by the script are not respected, then it will take the collateral. But in most of the cases, this will not happen, because we are able, since Cardano transactions are deterministic, we are able to evaluate fully the logic of the script before even submitting. So a proper transaction builder, such as the plu-ts one, will of course evaluate the Plutus script and tell you, hey, look, this script will fail, so you will lose the collateral. So in any real-world cases, you will not be able to even submit a transaction that is failing with the script. But in theory, you could not have this kind of checks before submitting. So you need to specify a collateral. In this case, well, of course, a collateral cannot be an UTXO from a script, because in order to spend that UTXO from a script, you still need to run the logic of a script. So it would require more collateral. Of course, this is a recursive problem. You will not be able to use collaterals from scripts. Instead, we will need to use collateral from some kind of human address, or at least public key hash. So that is why we have here my UTXOs that are actually the UTXOs present on the address, and on the address on our own address, and not the UTXOs present on the script address. So here we will just blindly select the my UTXOs at position 0. Here we will blindly select the first UTXO as collateral. Usually you just need like something like 5 to 10 ADA of collateral to be sure that this is enough. So now that instead though, we are using one of our own UTXOs and not only the ones of the script, we will of course need to sign the transaction to approve in case the script is failing the spending of this UTXO. So here we will now need to sign the transaction, and here we have it. And so now we can check once again if the Cardano node is happy with spending this UTXO. And here we get our transaction. We see that there are a bunch of information more than the usual transaction. So here we have our input from the script address. You can check here. Here we have our output that is exactly the input of the script minus the fee that is being paid, going back to the change address. And then we have some script data hash. This is automatically set by the transaction builder. You will not need to worry about this. There is the collateral input, as mentioned. And we see that this is our input from our address with some value. And we have the witnesses. We have signed the transaction. So this is our usual witness. We have another witness that is the redeemer. And this you can see as part of the signature of the script. And of course, we have the script source code. That is what we have included by specifying this script using input script. All it has done, this particular property is adding this in the witnesses. And we see that we have our transaction submitted. You can check it on our Eternal. And yes, we see that this is the transaction that we sent a moment ago, minus 10 ADA plus the fee. And this is the transaction that we just submitted literally a few seconds ago, where we have our collateral, the input from the script, as we saw in the JSON, and 9.8 ADA, which are the 10 ADA minus the fee, going back to our address. And in fact, Eternal is also saying us that this transaction resulted in us getting 9.8 ADA more. So this was a very simple Plutus script. All it did is just allowing whatever UTXOs it has to be spent at any moment by anyone. But usually you do not want to use this kind of script because it doesn't really add any logic. We are using this only to get introduced to how to write on-chain logic. But there is another very, very simple script that is very similar to this one that may have some weird utility. This other script is instead the always fail script. You can see it is the always fail because just like the always succeed, we are ignoring the first argument that we get for the contract evaluation, and we are instead automatically evaluating something called p-error with the type. This is a parameterized term if you want. But the important thing is that once this p-error is reached during evaluation, it is automatically thrown. So you do not have something like throw error. You just need to get in some way to this error here for it to be thrown and as fail transaction. By the same logic specified before, we can see that what we have here is a script that no matter what is failing. So the rule that this script is specifying essentially is you can never spend from this address. You cannot do whatever you are trying to do. This is what the script is doing. This is a pretty controversial, and this script instead is somewhat surprisingly used on the blockchain because, well, if you send some asset to the address that is generated by this source code, what happens is that you can no longer, never again, the assets that are under that address, because as soon as you run the logic in order to spend it, the contract fails and says, okay, the rule was not respected, so the transaction is not valid, and since the transaction is not valid, you cannot spend this asset. We can try to check out this behavior. We will now fund the script. Remember, we only changed the source, but we are still exporting the same script. So here, fund will get a different hash and a different address, and we can check that. We are funding, just like we did a moment ago, the script. This transaction is, of course, valid because, as I told you, the smart contract is not run when we receive. So when the smart contract receives asset, it does not run the logic. And we see that the hash, as promised, has changed, and with the hash, also the address of the contract has changed. And so now, these 10 ADA that are going to this address are locked forever. we can check that too, running npm run span. And now span, just like fund, as the address and the logic of the always fail. We do not change anything. We still need a collateral, because remember, if ever we submit this transaction, so if this transaction makes it to the blockchain, then the Cardano node will need to evaluate the transaction, and evaluating it will see that the contract fails. So in this case, if this transaction ever makes it to the blockchain, I will lose whatever collateral I'm spending here. However, we'll see that now by running this span file, the transaction builder throws an error so that the transaction is never generated. And of course, if I do not have the transaction, I cannot submit. The transaction builder is also giving us some nice information that will turn useful in the future to also debug more complex scripts. But of course, we know that this script is supposed to fail. It is telling us what is the data. We will see how to use this fancy X string here in order to debug in local our smart contract. We get the error message, and we see that an explicit error was reached. So the transaction, the rules specified by the Plutus script were not valid, or there are no additional inputs, and there are no script execution logs, which may or may not turn useful for debugging. So we see that there is nothing wrong with our transaction. The only thing wrong is that the script is not okay with spending that UTXO. And we know it's not okay because of the logic. It automatically returns false. So those stay data are actually burned, if you want, because nobody else can ever use it. So this is probably an utility of the always fail. It will allow you to burn whatever you want, even though it is not optimal. And there are specific ways to burn assets, and we will see how in the future. So this was our introduction to using scripts. This is the very basic of Plutus script. All we care about, and this is really important, all we care about in Plutus script is if we reach an error or if we don't. Just out of curiosity, I will change here the return type to be a Boolean, okay? And I will return here, of course, a Boolean. And just to let you see, I will return false. So a human, maybe, that doesn't know a lot of Plutus scripting and how do they work, would expect this contract to always fail. But since we know that in order to fail, we need to throw an error, and we are not throwing an error here, we are just returning a value that is Boolean for the Plutus, for the Cardano node. So for the blockchain, this script is the always succeed unexpectedly. So we can see this in action, of course. We will run npm run fund with this logic change. So since this is not the unit, the smart contract is actually slightly different, the on-chain. So here, our hash is different from the always succeed, but the logic is the same, effectively, from the point of view of the Cardano node at least. And so also the address is different. The transaction is our usual transaction, and it did make it to the blockchain. We can also go here and wait a second just to make sure that the transaction is on chain. We are sending to our new script. And so now we can run instead npm run span using this contract that return false. And we will see that this is, oh, I was mistaken. This is a nice thing to learn also for me. Actually, you do need to return a unit. I thought this was not yet implemented, but it appears it is implemented. You do need to return a unit. And we can see this from the return value. So this is actually an invalid contract, and I was surprised to learn with you that instead this can be considered, if you want, an always fail, because we are not returning a unit. Well, the more you know. Anyway, this was our introduction to Plutus scripts, and in particular Plutus v3 scripts, which have some additional features as we learn together. And in the next video, we will have a look at this very first field of the default argument that we get in order to run our script.